The first measures we're going to talk about are called measures of center. Now, center is kind of a vague term to mean kind of the thing in the middle, or literally a center is in a center of mass, or it can just mean kind of a typical or usual value. Those are all going to be thought of as like kind of the central measure, which is why we're going to have 4 different measures that we're going to look at that'll all be kind of getting at a center, but in a slightly different way. So the first one we're going to look at is the mean. Now, this is what in previous math classes you might have called an average, or, in kind of plain speak outside of a statistics class, we just call an average. Now, in statistics, we tend to want to use the word mean because, as we'll talk about in just a little bit, average can actually mean many different things. For example, when I say the average customer at a burger shop gets a soda with their order, when I say average customer, I mean like a typical, usual customer, not like I've literally like added them up and divided by how many there were, anything like that. So we tend to want to use the word mean to specify that that's the average that we're talking about. That said, because this is an intro course, I want things to be somewhat intuitive for you as we go through this. And as I talk about what the mean means, it gets a little bit confusing what the meaning of the mean is as I'm saying what the mean means. So when I say the word average, know that I'm talking about a mean. Now, if it's outside this class, sometimes you actually got to think about it and figure out what they're actually talking about. Are they actually talking about this thing that we've probably been taught since grade school? Or are they talking about something else? So this idea of an average has a lot of like loaded weight to it, right? When we talk about average, there's so many things like that should be common or typical, even though we were taught like a formula that, as we'll see in a minute, does not necessarily mean anything about common or typical. So let's look at that formula. So you may have seen it or more thought of it in terms of words, where I just simply add up all the values and divide by how many values I had. Now, when I write it as a formula, remember we went through that summation notation, that's the sum of all of my variable, let's say it's x, divided by the number of observations I have, which is my sample size, n. And the symbol I'm going to use for a sample mean is the variable with a bar over it. We'll typically, a lot of times use x. I'll use y quite often as well, so we'll just call it x bar or y bar, something like that. But it's this with a just flat bar over it. And it just means the same kind of average you've been taught for a while now. Now, this specifically is a sample mean. Right? We maybe don't think about that so often, but it's going to be important moving forward that we can distinguish between a sample and a population. We're going to use a different symbol when I'm talking about the mean for an entire population. Here I'll use the Greek letter mu, and that will mean the sum of all of, I guess, a census, right, because it would be the entire population, divided by the population size, which is when we use this capital N. Now, I don't want to focus on the formula because, as I talked about when we were talking about sampling, this census pretty much never happens. But this concept of mu being different than x bar is going to be important to us. And specifically, we're going to use this sample mean to make an estimate for a population mean moving forward. We're just doing descriptive statistics right now, which, remember, is just talking about what's in the sample, so we don't need to stress about that too much right now. I just want to get across the idea that these things are so importantly different to us in statistics that we're even going to use different symbols for them. The Greek letters are always going to be for populations, and we'll use English letters for samples. All right, so again, as I talked about before, I think you've all probably seen this before. So let's say our example here is going to be the number of times my wife has to ask me to take out the garbage before I actually do it. Now, this can be sometimes a high number or sometimes just one. But in any case, if I wanted to find the mean, what I do is I simply add up the observations I have, 1, 3, 7, 1, and 9. And then I divide by how many observations I actually have, which was 5 observations here. So when I do that, I get 4.2. So let's talk about that number 4.2. So first, is it like the most common value? right? Okay, so when we think of average, we tend to think of like a common, typical thing. Did 4.2 appear in the data set? Nope. 4 wasn't even there. So 4.2 is not really typical or common. Let's just say, is it at least even possible? No, I can't. My wife cannot ask me 4.2 times, right? This is kind of like that joke about the average family has 1.5 children, right? We're talking about averages here, and when we talk about a mean, that can get us nonsensical numbers, right? You can't have 1.5 children. We're just talking about what happens as an average. So really, if this thing's not typical, common, or even possible, is it at least like the center, I guess? And yes, but literally because of physics. So let me show you a picture here. So what I've got here is like basically a ruler that goes from 0 to 100. And I've put weights at 10, 20, and 90, right? Equal weights. So these are my 3 observations that I've got in my sample. Let's say that. 10, 20, and 90. Well, the place where I'd have to put a fulcrum, that's the balancing point, so that this thing will actually balance, is what the sample mean is. All right? So we'd call that in mathematics quite often a centroid. In physics, since these are equal masses, we'd call them a center of mass. This means nothing to us as we're talking about student ages or the number of times my wife asked me to take out the trash. Where that is a balancing point, like literally means nothing. As we move forward, we'll see that we can actually use this sometimes in a useful way, but all of that weight and baggage that's attached onto this word average when we think about it is kind of like incorrectly applied to the mean. And as we'll see moving forward, also, it's actually somewhat hard to interpret in real life. Like if this is literally just the balancing point for where to put a fulcrum so that things balance, that's really hard to interpret what a student age mean actually means then. So here's another way to kind of at least give us some kind of intuitive sense for this. My old professor used to call it the communist measure, okay? And here's why. All right, so let's say we're doing incomes, and we want to get some idea of what a mean income means, because, again, a balancing point doesn't really make a lot of sense here. So what am I actually talking about when I say the mean income for an area? Well, let's say this person makes $100,000 a year. This person only $10,000. Right, and then this person, let's make it a nice round number for doing arithmetic here. We'll make this one 70,000. Okay. All right. So what I'm going to do is I'm going to. I know this isn't even communist, but I think. But anyway, let's just say we just pull all these incomes together and give everyone the equal amount. Right? So that's what we're going to do, is we're going to say, okay, we want everyone to make the same amount of money. So if I find the average of this, it's actually 60,000, right? Yeah, that would be 60,000. So that would be up here. So what that means is if I evenly spread my values so that it's evenly spread across every observation, so across these 3 people, A, B, and C, if I evenly spread everything across everybody, that's how much that value would be. Now, that doesn't necessarily help us with student ages either. It's kind of like smoothing out the age, but honestly, I don't think I'd use a mean for student ages. I don't think that's a good measure. Instead, I'd use the median, which is our next video.